For months, astronomers thought they fully understood what they were observing. A frozen relic arriving from another star, a traveler older than Earth itself, drifting through our solar system for the very first and likely only time a comet. Yes, but an interstellar comet. Something so rare it is nearly impossible to calculate a cosmic messenger carrying chemistry from a different sun. But then, something changed. Something so abrupt, so violent, and so impossible to explain that even NASA hesitated to speak openly about it. Because according to the most recent analysis from Harvard astrophysicist Avi Loeb, 3-1 Atlas, the third interstellar object ever identified, may have experienced a catastrophic detonation breaking into at least 16 individual fragments somewhere near perihelion. And the strangest part is this: the evidence does not resemble a natural breakup at all. It looks structured, patterned, almost controlled. This is the story of how an object born around a distant star system may have either torn itself apart or activated right in front of us. And if the data holds true, we are standing at the edge of something unprecedented in the entire history of modern astronomy: the real-time destruction or transformation of an interstellar visitor. Tonight we dive deep into NASA's measurements, the James Webb Space Telescope's infrared readings, Hubble's size limits, and the British Astronomical Association's stunning images to uncover whether 3I Atlas truly fragmented and whether the layout of those fragments points to something natural or something far more unusual. Because once you see what astronomers captured in early November, you may never look at a comet the same way again. The story starts quietly. July 1st, 2025. Chile's Atlas Survey Telescope detects a faint object drifting into the inner solar system. At first, nothing appears unusual aside from the fact that it is interstellar, only the third such object ever found after Oumuamua in 2017 and Borisov in 2019. But in late August, the James Webb Space Telescope records something astonishing. With its ultra-sensitive NIR SPEC instrument, Webb detects a massive carbon dioxide gas coma spanning 348,000 kilometers, nearly the distance between Earth and the Moon. At this point, it resembles a typical comet, though unusually active. Except some of the chemical ratios inside that coma seem off. Iron and nickel appear in odd proportions. Certain molecules do not match expected patterns. Still, astronomers assume it must be the result of exotic interstellar chemistry. After all, this object formed around another star. Maybe it is simply different. Then September passes. October arrives. And as 3I Atlas moves closer to its nearest point to the Sun, the real anomalies begin to show themselves. As Atlas approaches, perihelion astronomers start observing something deeply unsettling. Instead of slowing down under the Sun's gravity, the comet is actually speeding up. The numbers tracked by Harvard reveal a radial acceleration of 1.1 times 10 to the power of -6 astronomical units per day squared, and a transverse acceleration of 3.7 times 10 to the power of -7 astronomical units per day squared. Together, these values create an overall increase of 94 kilometers per day squared at perihelion. To put that into perspective, the object was already racing through space at 150,000 miles per hour, yet somehow, it managed to pick up even more speed with no visible force acting on it. According to standard comet physics, the only possible explanation is outgassing. But if outgassing were responsible, Atlas would have to be shedding absolutely staggering amounts of material, and that is exactly what astronomers began calculating. From early August to late October, the mass loss rate skyrocketed from 330 kilograms per second to nearly 2 million kilograms per second, roughly a 6,000-fold increase. This is the moment alarm bells started ringing. This is where every model began to break down, because even for a comet under intense solar heating, this type of jump is absurd, like a frozen block abruptly transforming into a volcanic engine. Something inside Atlas was changing, something building, something pressurizing. And then the comet started glowing blue, an extremely unusual color for dust and gas from outgassing. Nature does not normally produce a blue glow unless something very specific and extremely hot is happening. Astronomers realized the moment of truth was coming. Here is where the entire comet interpretation collapses completely. At perihelion, the Sun delivered 700 joules per square meter per second to 3I Atlas. For the comet to sublimate enough ice to produce the observed mass loss, it would need a surface area of 617 square miles equal to a spherical body about 14.3 kilometers wide. But 3 weeks after discovery, the Hubble Space Telescope had already imaged the nucleus, and it could be no larger than 1 to 2 kilometers across. Not even close. 16 times too small, which leaves only one possibility. Either the comet somehow grew, which is impossible, or it shattered. This is the exact moment when Avi Loeb steps forward. Loeb notices something extraordinary. If 3I Atlas split into 16 fragments, each fragment would expose its own additional surface area, and the total combined area would match the needed 14-kilometer value almost perfectly. The math lines up. Too perfectly. 16 fragments produce 16 times the surface area, exactly enough to match the outrageous mass loss readings. This is not guesswork. This is not random speculation. It is cold, precise astrophysics, published by Harvard's leading theoretical researcher. And so, on November 10th, Loeb releases his analysis. 3I Atlas most likely blew apart into at least 16 separate pieces. But the Harvard paper introduces a much darker question, one scientists usually avoid asking. What if the breakup was not caused by the sun but triggered by a mechanism inside the object itself? If a comet naturally splits into 16 pieces, we should expect chaos. Random debris, uneven plumes, messy gas clouds drifting in all directions. But that is not what astronomers observed at all. On November 9th, British observers Michael Butner and Frank Nebling captured a sequence of images that changed everything. These were not casual amateur photos. They were high-precision, fully processed astronomical observations. The images reveal an anti-tail pointed directly toward the sun, a perfectly shaped anti-tail jet stretching 950,000 kilometers. Along with that, a main collimated jet extending 2.85 million kilometers. Far more structure and organization than any normal comet should ever produce. This is not random behavior. This is geometry. This is directional order. The very next day, astronomers Jagger Riemann and Prosperberry recorded at least 7 distinct jets, all lined up in a coordinated pattern. Natural fragmentation typically looks sloppy and disorganized. This, however, appears engineered. Loeb calculates that the comet is shedding 50 billion tons per month, yet the fragments remain coherent and stable. Something is powering these jets, and it is not simply ice turning into vapor. Astronomers attempt to push back. They remind the public that comets do break apart. It has happened before. Yes, Comet 73 P. Schwassmann, Wachmann fragmented. Yes, Comet Neowise behaved unpredictably, but natural fragmentation always leaves fingerprints. Rising internal temperatures, cracks, spreading uneven gas ejections, hazy clouds, chaotic jets pointing randomly. 3I Atlas shows none of those features. The jets are clean, straight, collimated, aligned. It is like watching controlled thrusters firing. Thermal models reveal that the internal temperature of the comet should never have reached the critical point required for a catastrophic breakup. The timeline does not fit. The physics do not match. The patterns do not behave like any known natural process. The official explanation is still a natural breakup, but the evidence itself is fighting back. At this point, Avi Loeb presents the hypothesis he knew would trigger immediate controversy. If natural comet behavior cannot account for the mass loss, the acceleration, the alignment of jets, the angular symmetry, the ecliptic alignment, and the surface area puzzle, then we must consider other possibilities. His exact words, technological thrusters can achieve much higher exhaust velocities than natural sublimation. Meaning, if Atlas were artificial, the fuel needed would be tiny. The mass loss would align with observations. The jets would appear collimated. The anti-tail could be intentional, and the acceleration would be easy to produce. He is not claiming it is a spacecraft. He is saying we cannot ignore any potential explanation. For the first time in history, a Harvard astrophysicist is openly telling the world that this interstellar object might not be natural. As of November 11th, 3I Atlas has emerged from behind the Sunday. And now, during the next 7 weeks, leading up to its closest approach on December 19th, humanity has a once-in-a-civilization opportunity to observe it up close. The Hubble Space Telescope will conduct ultraviolet spectroscopy. The James Webb Space Telescope will examine its molecular signatures. Orbiters around Mars have already photographed it during solar conjunction. Every major Earth-based observatory is preparing for continuous monitoring. Whatever 3I Atlas truly is, whether a shattered comet, an ancient relic from another star system, or something engineered, we are witnessing the truth unfold in real time. This is the most intensely studied interstellar object in human history, and after it departs in early 2026, it will never return. Any unanswered questions will remain unresolved forever unless we solve them now. As the final images of 3I Atlas flicker through telescope feeds across the world, something unsettling settles over the scientific community. Not clarity, not reassurance, but a heavy, almost eerie silence. Because for the first time since humanity learned how to track the heavens, we are witnessing the death or the transformation of an interstellar visitor in real time. And nothing about this breakup feels random. Nothing about it appears accidental. Instead, everything about it seems intentional, coordinated, almost choreographed, as if the object did not fragment because it was failing, but because it was completing something. Think about that. A comet born around another star system, older than any civilization Earth has ever produced, enters our solar system, carrying strange chemistry, impossible acceleration, organized jets, and a structure that defies every natural explanation. And then, at the exact moment when its mass loss numbers break known physics, it splits into 16 pieces. Not 15, not 20, 16. The exact number needed to solve the surface area problem that had left astronomers confused for weeks. It is as if the universe were balancing its own equation, and once you recognize the pattern, it is impossible to ignore it. The collimated jets that behave like thrusters, the anti-tail pointing toward the Sunday, the fragments spreading out with precision, not like chaotic debris but like petals opening. The color shift into electric blue, as if an internal mechanism overloaded just before release. The sudden spike in acceleration afterward, almost like the breakup, unleashed something, whether energy, direction, or purpose. NASA can label this a natural fragmentation event. Harvard can publish the physics with full neutrality. The British Astronomical Association can capture magnificent images of the jets, but not a single piece of this event behaves like an ordinary comet reaching its end. And that is what frightens astronomers the most. Because if this breakup was not natural, then what exactly was it? A self-destruction sequence, a planned decoupling, a release of independent probes, a mechanism triggered by solar proximity, a catastrophic malfunction of something ancient and technological, or something even more unusual, a phenomenon without a name in our vocabulary, born from physics. We have not yet discovered interstellar visitor or interstellar artifact. The truth is, no one knows, and maybe that uncertainty is the part that weighs the heaviest, because as the fragments drift apart, each carving its own path through the solar wind, each still producing clean directional jets, each glowing with that same unnatural blue hue, they resemble less a shattered ice ball and more a system, undergoing a transition, a metamorphosis, not a collapse, a message written through destruction, a purpose disguised as ruin. And as 3I Atlas continues to drift toward the outer reaches of the solar system, broken yes, but strangely functional, it leaves humanity not with answers, but with a question older than science itself. Are we witnessing the death of a comet or the rebirth of something constructed long before our species learned to look upward? Because if this object did activate itself at perihelion, if those jets were intentional, if the breakup occurred in a precise sequence instead of by chance, then we may have just observed the first interstellar machine in human history perform an operation designed eons ago, not meant for us, not directed at us, but visible to us nonetheless. And now, as it slips back into the darkness, only one thing is certain: we will never see it again. This was our single opportunity, our single moment, to witness a visitor from beyond, to examine it, to understand it, to listen to whatever message it carried. And whatever that message was, whatever truth it encoded in its silence and its motion, it now drifts across the void in 16 quiet fragments. If this story has left you wondering what else might be hiding in the darkness between the stars, do not let that curiosity disappear. Make sure to subscribe, because what astronomers will uncover in the coming weeks is only just beginning. Turn on notifications as well. Updates about the 16 fragments could arrive at any moment, and you will want to hear the latest the second they are released. And tell us in the comments, do you believe 3I Atlas broke apart naturally, or did we just witness the activation of an interstellar mechanism older than Earth itself?